A platform team I was advising rolled their AI coding tool out to about 40 engineers in a single week. The tool kept pausing to ask permission before it ran things, and 40 people hitting the same prompt got loud fast. So someone did the reasonable sounding thing and widened the shared settings so the agent could just run commands without stopping. They checked that change into the repository, and every engineer who pulled it inherited the same open door. A week later, one of those agents ran a cleanup script against the production database instead of staging. Nobody had told it which was which, and nothing was standing there to stop it. The tool worked exactly as it was configured, and that was the whole problem. It's the smallest corner of the professional architect exam, and still the one that quietly ends careers. So here is the question for the whole episode. When your entire team writes code with an AI tool, whose rules is it actually following? And what happens the moment faster quietly means less safe? I widened a setting to kill a prompt storm myself, so I get exactly why that team did it. I'll be straight with you though, because this domain is only about 7% of the exam. If you already hold the foundation certification, a good part of this is review, and I'll flag where. 7% means you learn it well enough to answer it, and you don't pour a week into it while a bigger domain sits untouched. Go back to that team because their real mistake wasn't the setting, it was the layer they put it in. When you set the tool up for a group, the docs give you several config scopes and they sort into 3 tiers you decide between. The first tier is personal, the files that sit on your own machine and belong only to you. The second tier is team, the files you check into the repository so everyone who clones it gets the same thing. The third tier is managed. The policy an organization pushes to every machine, the one layer an individual can't switch off. Personal, team, and managed, 3 tiers, and the whole skill here is putting each decision on the right shelf. Our team dropped a rule that needed a guard into the shared team layer as a wide open permission, exactly the scope mistake the exam loves to test. Now the part that catches almost everyone, and it's the single most testable idea in this domain. There are 2 kinds of files in play here, and they do completely different jobs. The first kind is the instructions you write for the model, the memory file describing how your project works. That file is guidance, the model reads it and tries to follow it, and most of the time it does. The second kind is settings, the permission rules the tool itself checks before it acts. Settings are enforcement. They get applied by the tool no matter what the model decides in the moment. If you write never touch production into that instructions file, you haven't built a wall, you've left a note. A note the model usually respects and occasionally does not, and the one time it does not is the day your database is gone. To actually stop an action, no matter what the model decides, it has to be a permission rule or a hook the tool enforces. This is the same rule from the safety episode wearing work clothes. If something must be true, you enforce it in settings or code, and if something should be true, you write it as guidance. 2 more facts make the enforcement side exam ready. When rules disagree, a deny beats an allow, and rules from different scopes merge instead of replacing each other. A rule set at the managed layer can't be loosened by a personal or team setting, which is why real guardrails live up there. So what should a team actually put in that shared layer if not a wide open door? The answer is the context every teammate needs and would otherwise be told by hand. The build commands, the test commands where things live, the conventions the project follows. Keep personal shortcuts and sandbox details in the personal layer out of the repository so the shared file stays clean. The same tool helps with the operational grind too, reading logs, tracing an error, drafting the fix. At this altitude, the exam doesn't ask you to memorize a flag. It asks what belongs to the whole team and what stays a personal preference. Here's the first one, and read it the way the exam wants, hunting for the constraint hiding in the middle. A team is standardizing the tool and wants to guarantee that no engineer's agent can ever run a destructive database command against production, while keeping everyone unblocked on routine work. Option A, add a line to the shared instructions file telling the model never to run destructive database commands. Option B, set a deny rule for those commands at the manage policy layer so no personal or team setting can loosen it, and keep an allow list for the routine work. Option C, ask each engineer to add that deny rule to their own personal settings. Option D, turn tool permissions off entirely and rely on code review to catch bad commands afterward. The load-bearing word is guarantee, and guarantee means enforcement, not guidance. A is the note on the wall trap. Guidance the model usually follows and sometimes doesn't, so it can't guarantee anything. C enforces the right rule at the wrong scope because personal settings are optional and per person. So one engineer who skips it reopens the hole. D treats prevention for detection, and finding the destructive command in review after it already ran isn't a guardrail. B puts an enforced deny at the one layer nobody below can override. So it's the only option that meets the word guarantee. The answer is B. Second one, and this time the trap is doing too much rather than too little. You are rolling the tool out to a new team and you want every engineer to share the same build commands, test commands, and architecture notes. But each engineer also keeps personal shortcuts and a private sandbox link they don't want in the repository. Option A, put everything shared and personal into the checked-in project instructions file so it's all in one place. Option B, have each engineer keep all of it in their own personal instructions file so nothing lands in the repository. Option C, put the shared context in the checked-in project file and keep the personal shortcuts and the sandbox link in a personal file that stays out of version control. Option D, copy one senior engineer's whole personal setup onto everyone's machine and call that the standard. Crams everything into one file and leaks the private sandbox link into source control, the maximal answer when the STEM asked for a clean split. B keeps the right content at the wrong layer, so the shared standard never reaches a new teammate who clones the repository. D is a standard in name only, because a copied personal setup isn't source controlled and drifts the moment one machine changes. C checks in what's shared and keeps personal what's personal, which is the clean split the STEM asks for. The answer is C. Let's put it back together before we close. Configuration lives in 3 tiers: personal, team, and managed, and you match each decision to the layer that fits it. Instructions are guidance and settings are enforcement. So anything that must hold becomes a rule. The tool enforces never a line the model merely reads. And a deny beats an allow, while a managed policy can't be overridden from below. The quiet lesson underneath all of it is almost anticlimactic. This is 7% of the exam, so the winning move is to learn it cleanly and then go study a heavier domain. Knowing where not to spend your time is its own kind of architecture. The biggest domain isn't this one, it's everything that happens when your system reaches out and touches the rest of the world, and that's where your study hours should go next.